Welcome to Train Signal. In this video, we're going to talk about classless interdomain routing, or what's more commonly known by the acronym CIDR. Now, I say the letters because I pronounce this acronym CIDR, but many people pronounce it CIDR, and I've even seen it pronounced as CIDR. CIDR, 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 don't really care what you call it. That's what we're going to talk about in this video. So we're going to start off by going over some of the problems that we have with class full IP addressing. Then we'll get into what CIDR and VLSM really are. And VLSM, I will tell you, stands for Variable Length Subnet Masks. And then we'll see how to subnet using CIDR. So what are the problems that we have with class full IP addressing? Well, the main problem is that we only have a choice between class A, B, and C networks. And a class A network supports almost 17 million IP addresses, whereas a class B network jumps all the way down to just a little over 65,000, or a class C, which goes all the way down to 254. And there's quite a bit of room in between these numbers. So an example would be, what would you do if your company had 2,000 computers and you needed 2,000 IP addresses? Well, your choice is you could go out there and get a class B range, but now you're going ahead and tying up 65,000 plus IP addresses when you only need 2,000, and therefore wasting more than 63,000 addresses. Or you could go out there and get 8 class C networks, and that would be pretty close to the 2,000 that you need. It would be just over. But now you're going to end up having cluttered routing table entries on the internet because your one network of 2,000 looks like 8 different networks to the internet. So the solution would be to go to classless interdomain routing, or CIDR, with variable length subnet mask, VLSM. Now here I've shown you an example of a decimal subnet mask, and you can see how it's all 255s and zeros because the line that we're going to draw that separates the network ID from the host ID, when we look at it in decimal fashion, we say, well, we could draw that line here, or we could draw it here, or we could even draw it here, which is where this subnet mask has been divided. And there's really no other choice. That's how we get A, B, or C. If we were to try to draw a line here in the middle, well, how do we know where that division really is? Whereas if we take a look at our binary subnet mask, you'll see that although right now the line may be between the ones and the zeros, this line can now move pretty much anywhere to the left or even to the right, anywhere at all, as long as it is somewhere in between one of the 32 bits that actually make up the IP address. Now, when you're using variable length subnet masks, you don't necessarily have to use only the numbers 255 and 0. See, all ones equals 255 and all zeros equals 0. But now, because we might be moving the bar somewhere in between, we still have to have all ones to the left and all zeros to the right. But basically, we could end up with one of the octets within a subnet mask being 7 ones and then a 0, which means that that particular octet will come across as 254 when we look at it in decimal. And we figure that out by going ahead and converting this number in binary over to its decimal equivalent. And I have the same thing all the way down here. There's a whole chart I have here of the different subnet mask entries that you could have, as long as the ones are on the left and the zeros are on the right. So if you've ever come across a subnet mask when looking at a computer that was not all 255s and zeros, this is the reason why. Now, let's take a look at how we would subnet using these new concepts. If we were to start with a B class range, meaning we have 255.255.0.0 as our subnet mask, but we now want to divide into smaller networks, we're going to go ahead and take some bits from the host ID and move them into the network ID. So down here I have a drawing where you'll see the original subnet mask. We have 16 ones and 16 zeros. And what we're going to do is take this line and we're going to move it this way. And the goal here is we want to satisfy that 2,000 computer requirement. So what we're going to do is we're going to move the line to here. And now what we have is we have our original network ID, and these ones right here have joined in with that network ID, but to just clarify the difference, we're going to call this the sub-network ID or the subnet ID. And now our host ID is a smaller range of bits. Now there's a couple of formulas that we use to figure out how far we want to move the bar when we're subnetting. The first one has to do with if you know there's a certain number of subnets that you need, well then you can factor in the number of subnets that will be available by taking 2 to the n. And n represents the number of ones in the subnet ID portion of your subnet mask. The other formula that we could use, and the one that we're going to use in this instance, has to do with if you know there's a certain number of hosts that you need, right? We know we need 2,000. Well, the formula is 2 to the n minus 2, but this time the n represents the number of zeros that are left over in the host ID. And the reason, by the way, that this is 2 to the n up here for subnets, and this is 2 to the n minus 2, the minus 2 is because the host ID, whereas in past videos I mentioned it cannot be all zeros or all 255s, well that was in decimal. Now that we're looking at it in binary, we see that the reality is that the host ID cannot be all zeros or all ones. And so those are the two choices that we would lose, and that's the minus 2. So in our example down here, the green ones were our original network ID, and we've now moved the bar over 5 spaces. And because we have these 5 ones in the subnet ID, that means that 2 to the 5th equals 32 subnets that can be made available within the original range. And more specifically, we now have 11 zeros left over, so 2 to the 11th minus 2 would mean 2,046 available hosts in each of those subnets. So if we take one of those subnets, that will provide us the 2,000 IP addresses that we need. So let's look at my network here. And this is a diagram you've seen a couple times before if you've watched the previous videos in this series. But there is one specific change that I've made, and that is right here. You'll notice the subnet mask is now 255.255.255.248. And I've also done it here on the router, and I've also done it down here on our server. What I've done is I've created a sub network which is much smaller than the original C-class network that we were using. Back when those were zeros, my network would support up to 254 hosts, and I've only got these 3. So why am I wasting over 250 IP addresses when I only need 3? But there is a problem with this network. It won't work. Why won't the network work? Well, here are the IP addresses that we had and the subnet mask that we are using. What we need to do is take a look at this in binary. When we look at it in binary, what we see is that this is our original network ID in green. In orange here, we have our subnet ID. In order for these 3 hosts to communicate with one another on the same network, their network ID must be the same, and as you can see here, although the part in green may all be the same, we've now added the orange part to our network ID, and they are not all the same. This one would not be able to communicate. It's on a different network. Now these two, they would both be on the same network, so they have to have unique host IDs, and they do. Oh, but wait a minute. This one has all zeros, which means that is not even a valid IP address within this network. So this network, the way I've set it up, is not going to work. Now what can we do to fix my network? Well, when you have a subnet mask of 255.255.255.248, each network is going to be broken into blocks of 6 host addresses. Now how do I know it's 6? Well, the reason why is, you remember, the formula is 2 to the n minus 2. Here we have 3 bits available for our host addresses, so 2 to the 3rd is 8, minus 2 equals 6, and I've illustrated that out by showing you all 8 possible combinations. Okay, that's what we have here. And in decimal, it would be 192.168.10.0 all the way through 7. Those are the 8 choices. And then you take away the 2 because all zeros and all ones are not valid. Why is that? Well, because 192.168.10.0 would represent the network ID. 192.168.10.7 represents our broadcast address. What that leaves us with is a range of host IDs from 192.168.10.1 through 192.168.10.6. So that would work. Another choice that could work is you'll notice that my subnet ID changed. Matter of fact, let me go back just a moment here to show you. See here, my subnet ID was all zeros, because in the subnet ID that is allowed. And then here, my subnet ID is now 00001. So this is a different network now. Matter of fact, this network ID is 192.168.10.8. Broadcast ID will now be .15, and we have a range of addresses from .9 through .14. But I'm going to go back, since this is a very simple network, I'm going to go back to the original ID that I had of all zeros, and I'm going to go ahead and pick the first 3 addresses to use. So we're going to use the 3 that are highlighted here, .1, .2, and .3 for our network. And here I've now illustrated my network, and now it has been fixed. My IP address on my router is now 192.168.10.1. My IP address on my server is .2, and the IP address on my client is 3. And now using the 248 subnet mask is completely valid. Now, the one last thing I want to talk to you about here is something called a CIDR notation. Because that's really what CIDR is. It's all about the notation. See, without the CIDR notation, we have an IP address and subnet mask written out as we see here, 192.168.10.1 with a subnet mask of 255.255.255.248. Whew, that's a mouthful. With the CIDR notation, all we have to do is say that it is 192.168.10.1 slash, and then we put a number after the slash which represents the number of bits that are in the network ID. Remember, an IP address is 32 bits in total, so the network ID in this case was 29 bits long, leaving 3 bits for the host ID. So there's really no need to have to write out the entire subnet mask anymore. We just simply use a CIDR notation. Okay, well, that brings this video to a close, and at this point you should now understand what classless interdomain routing is, as well as variable length subnet masks and how to use them.